All right, Chapter 9, Day 2. What we're going to look at today is what is the unit circle. It's kind of new for us. What is the unit circle, and how do we use it to find trig values? All right. So this unit circle is a circle with a radius of 1. All right. I know it's blown up really big, but this circle has a radius of only 1. So this value right here, 1. All right. If I were to list the coordinate points of where the circle hits the x and y axis, this would be 1, 0, 0, 1, negative 1, 0, 0, negative 1. So it's no different than when I draw a circle. Radius of 1 would be this, but that's so small I can't write anything in there. So I blow it up, and this is what it looks like. It's a unit circle because it has 1 unit of radius. Okay? So what we're going to do is we're going to draw a triangle anywhere. I'll just draw it here in the first quadrant to begin with. And now the radius of that is not 1, so I'm going to move this out of the way. Okay? So this circle has an angle, all right? We swept out an angle. How much is this angle? We're going to call this angle theta. Here's the symbol. Theta, theta, okay? There's our angle theta, all right? Now, this radius is 1, okay? If the sine of my angle is opposite over hypotenuse, here's my opposite, and here's my hypotenuse. Well, this point has some coordinates, x, comma, y. This is the y value. This is the x value. If sine is opposite over hypotenuse, isn't the sine of this angle just equal to the y value? Because y over 1 is still y. So the sine of theta equals y. Cosine is adjacent over hypotenuse. So the cosine of theta is x. In a unit circle. So a big thing to remember, in a unit circle, sine relates to the y value, cosine relates to the x value. You have to remember that, okay? Let's see how we can apply this information. All right, so let's take a look at a scenario. Let's say we have a point, square root of 3 over 2, comma 1/2, on the unit circle. Find the sine of the angle and the cosine of the angle. Well, first of all, these are both positive, so I'm in quadrant number 1. So I plot my point, okay, on the unit circle again. So here's my unit circle. I plot my point. My point is radical 3 over 2, comma 1/2. That's what was given to me. So I know that the x value is radical 3 over 2, the y value is 1/2. All right? Well, the sine of theta is opposite over hypotenuse. 1/2 over 1 is 1/2. The cosine is the square root of 3 over 2 over 1. So that's the square root of 3 over 2. So again, if I am given a point on a graph, all right, I can find the sine of the angle and the cosine of the angle, because if this is a unit circle, then the sine is the y value, the cosine is the x value. As long as it's on a unit circle, it has to be a unit circle for that to hold true. Okay? Let's take a look at what other things we can do. All right. So, given an angle of 120 degrees in standard position, so we did this today in class, we swept out 120 in standard position, intersects the unit circle, all right, so we're still on a unit circle, it still has a radius of 1, okay, determine to the nearest hundredth the coordinates of the point, all right, so I'm trying to determine the coordinates of this point. Let me hide them here for a second. Well, here's 120 degrees, okay? So the sine of 120 degrees, they tell me has a value of 0.87 when I type that into my calculator to the nearest hundredth. the cosine of 120 degrees is negative 0.5. Well, it should be negative because x values in quadrant 2 are negative. So this point has coordinates negative 0.5, comma, 0.87. So again, this would be negative 0.5 is my x, and this is 0.87 is my y. I can get this right from the calculator. All right, sine of 120, 0.87. Sine of, or cosine of 120, negative 0.5. There's my coordinates. Given an angle, find the coordinates. That's how the answer. Let's take a look at something else. What if the angle is not on the unit circle? Okay, so for example, if the tangent of some angle is 7/24 and it's not on the unit circle, right? So in other words, I no longer have a radius of 1. Find the radius, all right? Find the radius, and then find sine, cosine, and tangent of theta. So my angle is theta. Tangent is 7/24. And we're in quadrant 3. So I got to take all of these things into consideration. So quadrant 1, quadrant 2, okay? Quadrant 3. So my angle is in quadrant 3. My tangent is opposite over adjacent. And you might say, well, why did I list these as negative? They're negative because in quadrant 3, the y value is negative and the x value is negative. So this is negative 7 and negative 24. So again, I need to find this value since this is not on the unit circle. I got to find my radius, all right? I can call it r for radius. So, find the radius. Well, I have to use a squared plus b squared is c squared. So 7 squared plus 24 squared is c squared. And when you do the math, c turns out to be 25. So now I know that this is equal to 25. So the sine of the angle, again, here's my angle, and I can minutely call this angle right now, that's part of the triangle I'm in. Opposite over hypotenuse. So negative 7/25. Cosine of the angle, adjacent the x value over the hypotenuse. I cannot just say that negative 7 is the sine and negative 24 is the cos, because this is not on the unit circle. One other thing that you could use to find your radius is, to find your radius, you can use your Pythagorean triples. And I know you learned some of these maybe in 9th grade, maybe in 8th grade, but these numbers here are the common numbers that we use when we create triangles. So if you know them, you don't even have to do Pythagorean theorem, you just know that the other side is 25. So these are ones that I want us to have on hand to memorize to use. So when we come into class, we're going to do some problems with the unit circle, identifying sine and cosine and tangent, okay, of numbers on the unit circle. Given an angle, can we find the coordinates of that point? And given the value of sine, cosine, or tangent that's not on the unit circle, can we find the missing side, whether it's the radius or one of the x or the y, and find the sine and cosine values from there? That's it.